Space. You did a project on it in year 6. You glued cotton wool onto a polystyrene ball, you learned the order of the planets with a sentence about pizza, and then everyone agreed you understood space. You don't. Not because it's hard, because the version you were taught was a diagram. 9 circles on a poster, yes, 9, evenly spaced and sitting still. Almost everything interesting about space got left out of that poster, usually because it was too weird, too grim, or too inconvenient to fit on a wall. So here's what the poster left out. Start with the phrase itself. Zero gravity. You've seen the footage. Astronauts drifting through the space station, tossing sweets into each other's mouths, hair standing on end like they've been electrocuted. Zero gravity. Except the space station orbits about 400 kilometers up. At that height, Earth's gravity is still roughly 90% as strong as it is in your kitchen. It is not switched off, it is not even slightly tired. So why is everyone floating? Because they're falling. All of them. Constantly. The station is falling towards Earth at all times, and it has been falling for more than 25 years, and it has not landed once. That's not a joke about budget overruns. That's literally what an orbit is. Which brings us to the thing school genuinely should have led with. Getting to space is easy. A decent amateur rocket can touch the edge of space. The hard part isn't up. The hard part is sideways. If you launch straight up and stop, you come straight back down, and you have just built a very expensive firework. To stay in space, you have to miss the ground. You go up a bit, then you turn, and you accelerate horizontally until you're moving so fast that the curve of your falling exactly matches the curve of the planet underneath you. Fall, miss, repeat, forever. That speed is about 28,000 kilometers an hour. This is why rockets tip over shortly after launch, and why every child watching thinks something has gone wrong. Nothing has gone wrong. The tipping over is the whole point. Everything before it was just getting out of the thick air. Now, the bit the poster definitely left out. Take a human, remove gravity, and the human starts coming apart in slow motion. Your spine, no longer being compressed, decompresses. Astronauts grow up to 5 centimeters taller in orbit, which sounds like a perk, right up until you land, shrink back, and land with a sharply higher risk of a herniated disc. Astronauts' harmony tear at several times the rate of the rest of us. The fluid in your body stops pooling in your legs and migrates up into your head. Your face puffs, your sinuses block, and the pressure pushes gently on the back of your eyeballs until they flatten slightly, which changes your vision, sometimes permanently. It has a name, spaceflight-associated neuroocular syndrome. NASA reckons more than half of long-duration crew show at least one sign of it. Also, inside a pressurized spacewalk glove, the fit and the pressure make astronauts' fingernails peel away from the nail bed. It has happened right through NASA's history, in training as much as in orbit. Nobody puts that on the poster. Here's a stranger one. On the way to the moon, Buzz Aldrin mentioned something odd. With his eyes shut, in a dark capsule, he kept seeing flashes of light, faint streaks and dots that weren't there. He wasn't hallucinating, and he wasn't alone. Crews on Mir and the space station report them too. What's happening is that cosmic rays, high-energy particles fired out of dying stars and things considerably worse, are passing through the spacecraft, through the astronaut's skull, and directly through their retina and optic nerve. Your eye registers the interference as light. So the flashes are real. Something genuinely is passing through your head. You are, briefly, a detector. Out past Earth's magnetic field, where there is no shielding at all, the rate climbs sharply. Apollo crews saw them roughly once a minute, and mostly at bedtime. They were being shot through the brain, and it kept them up. The moon looks soft, gray, powdery, a bit like ash, it is not ash. On Earth, dust gets worn smooth by wind and water. The moon has neither. What it has instead is billions of years of micrometeorite impacts smashing rock into fragments and flash melting them, which leaves particles that are jagged, glassy, and microscopically sharp, closer to shattered fiberglass than to sand. It also holds a static charge, so it clings to everything and won't brush off. Apollo crews tracked it into the lander. It ground into their suit seals and wore them down. It ate the finish off their visors. Harrison Schmitt breathed it in and got congested and streaming-eyed. He called it lunar hay fever. And when it hit the cabin air, it gave off a smell the crews all recognized: spent gunpowder. Nobody has fully explained why. Stay on the moon for one more, because this one is genuinely unsettling. Apollo 12 left seismometers on the surface. Then, on the way out, they deliberately crashed their empty lunar module ascent stage back into the moon to give those instruments something to measure. The moon rang. Not a thud, not a shudder, a reverberation that carried on for the better part of an hour, the vibration rolling around inside it and refusing to die away, the way a struck bell does. Later impacts produced the same thing. Some lasted hours. It is not hollow, whatever the internet tells you. It is dry and deeply cracked, with nothing inside to damp the shaking. Still, you hit it, and it rang. And it kept ringing. Now, let's leave the neighborhood. You are not sitting still. Earth spins and orbits the sun, and the sun orbits the galaxy. You probably got that far in school. But the whole Milky Way is also moving at roughly 600 kilometers per second. And it is moving towards something. For decades, nobody could see what. The direction it's headed happens to sit directly behind the crowded, dust-choked center of our own galaxy. A patch of sky astronomers call the zone of avoidance, because you simply cannot see through it in visible light. So there was a thing pulling on everything we know, and it was hidden behind the one obstacle we can't move. They named it the Great Attractor. X-ray and infrared astronomy has since seen through the murk. There is a huge cluster of galaxies in there, and it is pulling. But we don't stop at it. The flow carries straight on past, towards something bigger and further out that still isn't fully accounted for. Here's a question that sounds childish and isn't. Why is the night sky dark? Think about it properly. If the universe were infinite and eternal and full of stars, then every single line of sight you took, in any direction, would eventually land on the surface of a star. Every point in the sky would be as bright as the sun. Night would not exist. You would be standing inside an oven. Astronomers argued about this for centuries. It's called Olber's paradox, and it is not resolved by saying the stars are far away. Distant stars are dimmer, but there are proportionally more of them, and it cancels out exactly. The actual answer is that the universe has not been going long enough. Light from the most distant stars hasn't reached you yet, and expansion has stretched what did arrive out of visible range. The darkness between the stars is not empty. It's a deadline that hasn't passed. You've probably heard that the sun will swell up and swallow the Earth in about 5 billion years. True. Also irrelevant, because the interesting deadline is much closer. The sun is slowly getting brighter, around 10% per billion years. As it does, Earth gets hotter, and hotter rock weathers faster. And weathering rock pulls carbon dioxide out of the atmosphere and locks it away in stone. It's a thermostat. It has been quietly protecting us for a very long time. The problem is that plants need carbon dioxide. Run that process forward and the level keeps dropping until it falls below what photosynthesis can work with. Most estimates land near 1 billion years from now. The most recent modeling pushes it further still. plants fail, then everything that eats plants fails, then everything that eats them. The sun doesn't kill life on Earth. Life on Earth suffocates, in a still comfortable temperature, a very long time before the fire. One last one, and it's the one that'll matter in your lifetime. In 1967, most of the world signed a treaty saying that no country can claim ownership of the moon or any other body in space. No flags that count, no borders. It's still in force, and every spacefaring nation is still signed up. There's a gap in it, though. The treaty says a nation can't own the moon. It doesn't clearly say a company can't own what it digs out of the moon. Several countries have now passed domestic laws stating that if their citizens extract space resources, they get to keep them. So the legal position is currently that nobody owns the moon, but the water at its south pole may well belong to whoever gets there and pumps it first. That's not a settled question. That's a starting gun. None of this was hidden. It's all in papers and mission transcripts and textbooks nobody assigned you. It just didn't fit on the poster, because the poster had to be simple, and space refuses to be. The cotton wool and the polystyrene ball weren't wrong, exactly. They were just the first 2%. If you want the next 2%, there's another one of these on the way.